I love how both realistic and crazy the monsters are in Monster Hunter, and especially Monster Hunter Wilds, from the realistic massive spiders like Nasilla and Lalabarina, to the monsters that seem to be one with their environment, like Balahara and Congalala. But then you just have pure crazy spectacle like Gogmasios or Arkveld. However, one monster easily takes the spotlight as the best blend of a crazy over-the-top fight and feeling plausible, which is none other than Rey Dau. Moreover, his ability to create massive columns of fulgurite that are far larger than anything you would find in nature, which led me to wonder, how much energy is this apex predator outputting? This is a physics patch, where we use physics to update our knowledge of games. In this video, we're going to be applying the physics patch to Monster Hunter Wilds. I knew I wanted to get a rough volume for the fulgurite produced, so first I had to measure my hunter. I explored the Forbidden Lands until I found a monster that displayed its length using the binoculars. Luckily, I found a Chatacabra, which I could put my hunter next to and safely measure. Unsure about how the game's measurement for the Chatacabra and its skeleton lined up, I did a few repeated measurements and got a height for a hunter around 175 centimeters, though some measurements gave values around 170 centimeters and 180 centimeters. Now, when I said this is the physics patch, I kinda lied. With all of the rough estimates that we're about to do, this should actually be the engineering patch. Placing the hunter up to the fulgurite crystals and measuring their dimensions, a very rough estimate can be made of the observable volume to be 1.91 meters cubed for each of the 3 fulgurites, and the bigger fulgurite column to be 14.9 meters cubed. Now, how do we get the energy of a lightning blast from this? The process of sand becoming fulgurite has a lot of very cool physics going on. But all we really need to care about regarding our calculations is the energy to heat up and melt the sand, which is given by E equals m times C del T plus Lf, where m is the mass of the heated sand, C is the specific heat capacity of sand, del T is just a change in temperature, and Ls is the latent heat of fusion, which is just the energy to break sands down from a solid into a liquid. Quick note, this assumes uniform heating, which would likely overestimate the required energy. Mass is just density times volume, but the volume we observe is not the initially heated volume. With mass being conserved, we can use the density of sand times volume of sand equals the density of fulgurite times the volume of fulgurite and rearrange for the following equation. With a density of sand of 1.6 grams per centimeter cubed and silica of roughly 2.4 grams per centimeter cubed, we get the following equation. But fulgurite also contains a hollow core, which we can take to be some ratio phi, which for this video represents a fraction of the observed fulgurite volume that is actually solid material, where 1 is completely solid and 0.5 is 50% hollow, including some coefficient eta for the efficiency of the process, with 1 meaning all the energy went into the fulgurite formation, and 0.1 meaning only 10% of Rey Dau's energy went into the fulgurite formation, we get an equation proportional to the density of the sand times the expansion factor times solid volume times thermal energy, all divided by the efficiency. By destroying the fulgurite's columns and using the extremely advanced scientific method of guessing when looking through footage slowly, while noticing how easily the small columns were being destroyed, got a value for phi s of the small columns to be around 0.5 and a little less than 10% for the big column, so phi b let's say is 0.08. Plugging in the rest of the values, we get a final energy for the fulgurite being created as 15,502,932,960 joules. Unfortunately, there's a lot of uncertainties and estimates. Since it's a focus strike, we can take eta to be 0.2, which is already quite generous, seeing as regular lightning is around 0.1% efficient, for a total energy of 77,514,000,000 joules, around 70 times stronger than a typical lightning strike. But is what I would guess, considering this is a concentrated railgun of lightning. If you take the fulgurite to be more solid, which the crystal seen from the outside can suggest, even changing the values a bit to phi s equals 0.8, phi b equals 0.1, and eta equals 0.1, we could get a ridiculous answer of 232 billion joules, which is over 200 times stronger than your average lightning strike. Unfortunately, that uncertainty is unavoidable when it comes to making calculations in fictional worlds with a lack of interactivity with your typical measuring instruments. But that's a sacrifice I'm willing to make on the engineering patch. So while Rey Dau might look like just another lightning monster, what it's actually doing is far closer to a highly focused, energy efficient discharge than anything we see in nature. I hope you enjoyed the brief dive into physics in the world of Monster Hunter. If you enjoyed the video and the concept of this channel, be sure to leave a like and subscribe for when I have the free time to make another video. See ya.